This tutorial will guide you through the prompts on page 191. So 191, and our first prompt is, it says to draw a line to model the linear relationship seen in the graph. Then write the equation in slope-intercept form. So slope-intercept form, what this means, slope-intercept form, is to write the equation in the form that uses the slope and the y-intercept of a line. So we're always going to say y equals, and then the slope is represented with the letter m, and the y-intercept is represented by the letter b. So this is called slope-intercept form because we're going to figure out what the slope of the line is and fill it in there. And then we're going to figure out what the y-intercept of the line is, and then we're going to fill that in here. So when it says to draw a line, what it's referring to is to go back to page 190 and to draw a line that goes through these points. So get a straight edge or a ruler or the edge of your protractor, anything that's straight, and draw a line that goes from here all the way through these points and then keeps going. So you'll want to draw your line from beyond the points. So starting up here somewhere, draw through the points and then keep going. Because it's really important that you keep going through here so that you can see where the y-intercept is. So here's an example of the line that I drew. You can see that it starts beyond the points up here and it goes through all the points, and then I can see where my y-intercept is. Okay? That's really important. So draw that in your book, and what we're going to do is we want to write an equation that's in slope-intercept form, like I mentioned before. So we need to identify the slope and the y-intercept of this line. And the slope, we're going to substitute our number for slope in for the m, and we're going to substitute our number of the y-intercept in for the b. So let's get the y-intercept first. When I look at the y-axis, see how this is the y-axis? The vertical axis is y. Right here is where my line goes through the y-axis. And since this is 0 and this is -4, I know that this point right in between 0 and -4 is -2. So my y-intercept is -2. Now, when I'm calculating my slope, I can choose any 2 points on the line. So I'm going to pick any 2 points I want, right? So I'm going to choose this point right here and this point right here. But you don't have to choose those points. You could choose any 2 points that are on this line. All right, so to calculate my slope, I want to do the change in y, that's the vertical change, the up and down change. So how far is the distance between this level of this point and the level of this point? So I want to look at my y-axis and see how far is it from here to here, because that's this distance between this point's level and this point's level. Then I also need to calculate the change in x, or the horizontal change. So to calculate the horizontal change, I need to look at this distance from the location of this point on the x-axis over to here, the location of this point on the x-axis. So here's my horizontal distance. And so on the x-axis, that's between here and here. So this distance is the same as this distance. This distance is the same as this distance. We have the vertical change over the horizontal change. So here we go. Let's calculate the horizontal change first. So this is 10 and this is 14 because 10 is right between 8 and 12 and 14 is right between 12 and 16. So what is the difference or the distance between 14 and 10? And that distance is 4. So you could also think about this way. If I go from 10 to 14, I'm going up 4, right? Because each of these lines is 2. All right, so now what's our horizontal change? I'm going from 3 to 4. So since I started, you want to be careful with slope and start with the same point each time. So since I started with 14 before, and 14 is dealing with this point, if you're doing the math, you'll want to start with this point on the bottom too in the denominator. So since 14 is this point, I'm going to start with 4 because that's also this point. So 4, and then I want to know the difference between 4 and 3. And that's 1. So my vertical change is 4, and my horizontal change is 1. And so that means that my slope is 4, because 4 over 1 is the same as 4. So now I have my formula in slope-intercept form. It's y equals 4x plus negative 2. But instead of saying plus negative 2, remember that it's the same as saying this plus negative 2. Remember that when you distribute, this is like multiplying 1 times negative 2. So when you multiply 1 times negative 2, that's just going to come out to negative 2. So you don't have to write plus negative 2. You can just write negative 2. So 4x minus 2. So here's your equation in slope-intercept form. Sometimes you'll see the slope equation. So I just want to introduce that quickly so that you know it if you see it. So it's the same thing as saying rise over run. It's the same thing as saying vertical change over horizontal change. There's nothing that's different about it, but it takes a different form. So some people get a little confused about it because it looks different. That makes sense to be confused because something looks a little different. So sometimes you'll see the slope formula. Instead of looking at a graph and counting vertical change over horizontal change, you'll just see a formula. And you'll see something like y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, this looks really complicated, but really it's not so bad. What you do is you just write down the coordinates of your 2 points. So for example, this point right here is 3, 10. So one of my points is 3, 10. And again, you could choose any 2 points on this line that you wanted. I just happened to choose 3, 10. And then I also chose this point, which is 4, 14. So this is my second point that I chose. Now, what you do is you just decide which point are you going to call point 1 and which point are you going to call point 2. Now, it doesn't matter which one you choose, but because I see that these numbers are bigger and I'm subtracting, I'm just going to make it easy on myself and use the larger numbers first so that I don't get negatives. But it doesn't matter. You could totally do it the other way. So what I'm going to do is I'm going to label, right? These are our x's and these are our y's. And this is an x and this is a y. And then I'm just going to give them the numbers that I want. So I'm going to call this point 2, and so I'm going to put 2's by this x and this y, and then I'm going to put 1's by this x and this y. Now all I have to do is plug these numbers in the right place. So y2 is 14. I'm going to write over here so I have more room. 14 is y2. And then write down the minus. Don't forget to always write down the minus. Then y1 is 10. x2 is right here. It's 4. And x1 is right here. It's 3. Notice I did not forget to write down my minus. Okay. And now you just do the math. 14 minus 10 is 4. 4 minus 3 is 1. And then 4 divided by 1 simplifies to just 4. So see how we got the same number, whether we counted the distance or whether we used the formula. All right. Now, I challenge you to do this calculation in the other order. So if you want to challenge yourself and prove to yourself that this will turn out with the same answer, no matter which point you call point 1 and point 2, I challenge you to do this. Change your points around so that this is point 1 and this is point 2. But be very careful to leave your minuses here, because you're going to end up with some negative numbers in the mix, okay? So don't let that throw you off. That's fine. When you simplify, you'll get the same number.